Hi there. How are you doing today? Ready for your training? Sorry for the mess. Still a lot of work around here. The way is blocked behind me. Head in via this side alley. A helicopter is waiting for you near the lab.
You'll have to jump over these boxes. Don't worry, they're pretty solid. Sorry about that. We're in the middle of some moving. Continue that way. Watch out for the wreck. Just crouch and go straight on.
Hey, could you please grab that crate and place it on the trailer next to the other boxes? No. Put it with the other crate, on the trailer right there. No. Put it with the other crate, on the trailer right there. Thanks, buddy. You should head for the helicopter now. They're waiting for you. Good luck with your training. By the way, might be a long trip. Get some water in the warehouse before leaving.
Hey there. Man, I'm exhausted. I need a break. Thirsty? Help yourself at the water station. The flight might take a while. You should probably take some water with you. There are some empty water packs in the container over there.
This is the inventory screen. On the left is the container's inventory, and your inventory is on the right. Drag and drop an item from the container's inventory to a free slot in your inventory. Some items have specific functionality, linked to being in the corresponding device's inventory. To access an item's action menu, hover the mouse over its icon and press the right mouse button.
There's a medical tool in the open box. Take it with you as well, just in case.
Items on the ground can be seen at the top of the inventory screen. Some items have a special slot type where only their type can be placed. For example, the medical tool can be placed in your tool slot. If you drag an item over the wrong slot, it will turn red. Otherwise,
You should equip the tool if you want to use it. You'll likely find many tools that come in handy during your training. Feel free to put away the medical tool once you've done with it. Anyway, you should head to the chopper, man. They won't wait for you all day. Have a safe flight, and good luck.
Hey, ready to hit the Martian dust? Well, the next best thing anyway. Just hop in and grab a seat. We're about to take off.
Actual, I'll be your pilot today. Welcome on board. Make yourself comfortable and we'll take this boat. Okay, let's see. Engines go. Fuel is go. Torque is go. Looking good. Raising collective. By the way, training island, you'll love it.
Welcome to Training Island. This complex is used for training our future astronauts to survive a stay on Mars. The wooden panel indicates the locations such as the completion of all training facilities. Use it to choose your next training area. Here you'll learn how to drive and operate vehicles you'll make use of on Mars. Let's start with a cargo truck. To board the truck, walk up the stairs. Use this button to stow the stairs. Similar buttons are located on each outer side of the truck. It takes some time for the stairs to stow completely, so make sure they're in a safe position before driving. The cabin is accessed via an airlock. Be sure to close the airlock's outside door before opening the cabin's door. I'm sure you'll have noticed two suit holders, one at each side of the airlock. On Mars, you can store your suit there to refill its oxygen supply and power. Now open the airlock cabin's door. Don't forget to close the airlock. On Mars, both seats allow you to drive the vehicle. You can sit down by pressing the use key. Put your hands on the wheel. We have prepared an obstacle course for you. While driving, the monitor can give you various information about the vehicle. Turn it on with the mouse cursor at your convenience. Press the right mouse button to display or hide the mouse cursor. Drive carefully over the first series of obstacles. You may monitor your cargo using the rear camera on the monitor. This vehicle has a wide turning circle. Keep that in mind when turning and move to the next checkpoint. Most vehicles have a turbo mode for increased speed. To climb up steep slopes, use turbo by holding the turbo key. Note that the turbo mode uses more fuel. You can watch your speed and fuel levels in the stats menu in the vehicle's monitor. Stop the vehicle and check the cargo. You can loop between the different external cameras by pressing the camera key several times. Drive the truck carefully down the slope, then park it at its final spot. Okay, you can stop here. You can leave the seat by pressing the use key twice. Now let's move on to the scout buggy. Move through the airlock the same way as you did before. Make sure that all doors are properly closed. Extend the ramp by pressing the ramp button. Ramp controls are also on the outside of the truck, rear right, next to the ramp. The cargo bay is narrow. Don't hesitate to climb over the buggy to reach its driving seat. Sit in the buggy seat by pressing the use key when it's highlighted. Now reverse out of the cargo truck slowly. All vehicles share the same control system. Use the vehicle's monitor to watch its data and hold the turbo key for increased speed. The Scout buggy is much faster than other vehicles, but has a small fuel supply. Its low clearance makes it vulnerable even to small objects. vehicle burns fuel, methane and oxygen. Let's move close to and look directly at one of the barrels and press the use key when it is highlighted. You can rotate held objects by holding the rotation keys while moving the mouse. You may also rotate by 90-degree increments with the additional rotation keys displayed below the objectives panel. The Scout Buggy's cargo hold is opened automatically when you are near it. Place the new barrel at the tank's plug and drop it when it's highlighted to connect it. Great job! You've successfully mastered the buggy. Now is the last part of the vehicle's training, the manned mobile laboratory. The MML's airlock has a control panel. Press extend to extend the ramp. Stay clear of the ramp when it's moving. It's heavy and can cause heavy injuries. You may now retract the ramp and wait for it to close before entering the MML. The MML's airlock is, as you can see, different and spacious. The airlock has 6 slots for oxygen-filled barrels and 2 suit holders. The body of the MML contains storage, beds for the crew to sleep, and a work table to perform various analyses. 2 panels control the side doors, but only if connected to a habitat. Turn on the display by clicking it with the left start by rotating the crane towards the container by pressing the your right or your left buttons on the screen. Now use the pitch up down and extend retract buttons to position the magnet above the container. Now, position the magnet within proximity of the container using the lower raise buttons. Now, press the Activate Magnet. Great! Use the crane controls you've just learned to move the container to the other side of the MML. Raise it off the ground first. The rest is up to you. The container is close enough to the ground now. Press the Deactivate Magnet button to release it. Perfect. This concludes the MML training. Congratulations! You successfully completed the vehicles training. Use the wooden panel to move on to the next part of your training. This facility contains all the machines and equipment you will need to survive on Mars. We will begin with a presentation of power generation machines. This is the radioisotope thermoelectric generator, also known as RTG. Learn more by using the speaker. The RTG is an electrical generator utilizing the thermoelectric effect. The electricity is produced through the conversion of the heat released by the decay of radioactive material. Despite an output of only a few hundred watts, the half-life of the used isotope provides the capacity for a constant power supply spanning many years. It is provided with 2 standard output sockets and a standard display. Let's plug in the power cable. We are going to use the RTG shortly. This panel displays on the left the electrical power generated by the RTG, and on the right its draining load. The load is currently at 0 as it is not connected to any machine. Great! Now move on to This is a communications tower. It serves as a beacon for your map. Knowing your exact location, such as of your crew and your machines, is vital on Mars. Hence, communications towers create an information network when they are in range of each other. Your interactive map will connect to the nearest comms tower and displays information about anything covered by the network. If there is another comms tower in range, it will connect to the existing network of comms towers and expand the area you can see. Now, we can supply this comms tower thanks to the RTG. The communications tower is operational now. Use the map key to open it. Good work. Now proceed to your next objective. A cable spool can contain up to 5 power cables. As a cable is 10 meters long, they are rolled up on the spool for easier transport. Learn more about power cables by using the speaker. Power cables have a red end and a green end. The red is for input, for example to a machine producing energy like the RTG, and the green is for output, for example to a machine requiring energy like the communications tower. Observe the sockets on each machine. The color code will inform you about the correct connection, red to green or green to red. You can unwind the cable by clicking on the spool with the unwind key. To rewind the cable, just grab the cable and hold it onto the spool, then press the same key again. Easy, right? Now grab that cable and rewind it onto the cable spool. Now that you've learned how to handle power cables, move on to the power hub. This is a power hub. It serves as a connector bridge between power generators and machines. The power hub has 6 red input sockets on the right and 6 green output sockets on the left. It allows you to connect a maximum of 6 power generators to the input sockets and distribute power to up to 6 machines via the output sockets. The display on the left shows the sum of power generated in the electricity network or grid expressed in watts. The right shows the current electricity load. The bottom line informs about the power stored in the hub batteries and the estimated load duration. As you can see behind you, you can connect several hubs together to reduce the amount of cables needed for supplying the machines with electricity. Plug that cable to an input socket before we move on. Now, it's time to have a look at the solar array. A solar array, also referred as a solar panel, absorbs the rays of the sun and processes them into electricity. The solar array is made of two panels that convert the solar power to electricity, utilizing the photovoltaic effect. Two additional batteries can store up to several kilowatts per hour of electricity. One solar array can generate over 2 times more power than the RTG. However, its efficiency depends exclusively on the amount of solar energy available. It's also provided with 2 output sockets and a power display. Now plug in that cable to connect the solar array to the power hub. Great! You now have the required knowledge about power generators for your future mission on Mars. That should come in handy. We will now focus on the different machines you will have at your disposal. Please proceed to the machines area. Each machine comes in 2 versions, a large one and a small one. We will start with the topsoil extractor. This is a topsoil extractor. Its sole function is to extract the soil from the surface. The topsoil extractor uses a flexible hose to gather the surface of the soil in the same way as a vacuum cleaner. The extracted resource is collected into barrels that must be plugged in prior to its usage. It has 2 input sockets for its energy supply, such as a standard display informing about its energy usage. The large topsoil extractor, like this one, proposes 4 barrel plugs. A small version, less energy demanding, The topsoil extractor uses a flexible hose to gather the surface of the soil in the same way as a vacuum cleaner. The extracted resource is collected into barrels that must be plugged in prior to its usage. It has 2 input sockets for its energy supply, such as a standard display informing about its energy usage. The large topsoil extractor, like this one, proposes 4 barrel plugs. A small version, less energy demanding, embarks only 1 plug. Use that cable to supply the topsoil extractor so we can use it. Perfect. Now that the machine is powered, you have to plug in the resource barrel for it to start working. There should be one lying near. Now, connect the barrel to an empty slot. When properly supplied with energy, the machine starts to operate immediately. Perfect. We can now continue with the atmospheric processor. This is the atmospheric processor. It captures the surrounding atmosphere. The atmosphere is drawn in through an air pump and redirected into resource barrels that collects the air. The large atmospheric processor accepts up to 5 barrel plugs, whereas the small energy efficient atmospheric processor proposes 1 plug only. Connect the cable so we can collect the Earth atmosphere. Perfect. Now that the machine is powered, you have to plug in the resource barrel for it to start working. Now, connect the barrel to an empty slot. When properly supplied with energy, the machine starts to operate immediately. Let the processor work and move to the drilling rig. This is the drilling rig, used for excavation. A twist drill bit penetrates the crust with a fast rotation. The raw material is then lifted up through a borehole via the cutting edges. The extracted rock is stored into barrels. This large drilling rig proposes 4 barrel slots and a standard display panel, while the small version has 1 plug. connects the machine to a cable so we can dig up some earth rock. Perfect. Now that the machine is powered, now connect the barrel to an empty slot. When properly supplied with energy, the machine starts to operate immediately. On each machine, do not omit to pay attention to the power display. You can monitor the machine's energy requirements, the overall power available on the grid, and the potential usage duration. Do not forget that a machine cannot operate with barrels filled with improper resources. For example, an earth soil barrel plugged to a drilling rig. If you do so, the machine will just stop working. Do not get confused. Let's move on to the next machine. This is a materials refinery, a beautiful piece of engineering that can refine raw resources into materials or compounds. The materials refinery has two main functions. It can either split complex materials into their constituent components, or it can synthesize compounds from core materials. Input and output slots are located on each side of the refinery. The large materials refinery comes with 3 input and 5 output slots. The small one has respectively 2 input and 3 output slots. A control panel allows for the operations of the desired reaction. Plug in the cable so we can start to put our hands on this machine. The refinery is now powered. Why don't we try it out on some raw material we've just collected? Let's split some rock. Take one of the earth rock barrels from the drilling rig and plug it into a free input slot of the refinery. Remember, input slots are on the left of the materials refinery. The input barrel is connected. Now, earth rock's second splitting reaction produces 4 elements, so we need 4 output barrels. This barrel is partially filled with oxygen, which is one of the elements of the splitting earth rock's reaction. Plug it into a free output slot at the right side of the refinery. Good job! Now move to the control panel. We will finalize the last parameters. Here is displayed the reactions list screen. It shows all the reactions the materials refinery is capable of processing. Select Split Earth Rock 2 to access the reactions details, required input materials, and expected output components. In our case, 5 units of earth rock, the input material, will generate 2 units of oxygen, 1 of silicon, 1 of aluminium, and 1 unit of iron, the 4 output components. To navigate through the control panel, use the centered mouse cursor, not the free cursor. To ease the reading, you can hold the zoom key to zoom. When you're ready, close the reaction list screen to access the processing screen. The processing screen permits you to manage the reaction according to the raw material in input. Select the input slots, earth rock in our case, with the left mouse button. Now, select all the output slots. Keep in mind that an incomplete or improper selection will cause an interruption of the process. Once all the correct slots are selected, the reaction is ready to be performed. Click on the process materials to proceed. And voila! When the materials refinery is processing, you can monitor the decrease of the input material and the production of the output components as you wish. Now let's move on to the next device. This huge thing is the resource tank. It is used to store large quantities of resource. 2 input slots for transferring from a barrel into the tank and 2 output slots for collecting the stored resource into individual barrels, plus a simple display for capacity monitoring. It's as simple as that. Let's completely fill that oxygen barrel. Plug it into an output slot of the resource tank. As you can see, the quantity of resource decreases from the tank, filling up the barrel until it's full, or until the tank is depleted. The materials refinery should now have produced enough oxygen from the earth rock. Bring it to the resource tank. Observe the oxygen of the barrel being stored in the resource tank. No need to say that you can't plug in the barrel whose resource differs from the element stored in the tank. We're almost done. The last thing to learn is the 3D printer. Go through the gates to the printer testing area. Two types of 3D printers are available. We will start with the Creative Printer on your right. This is the Creative 3D printer. It's a user-friendly type of printer. The Creative 3D printer is able to build any machine or equipment you've ever dreamed of. It doesn't require any resource or power, and the printing duration is very short. The printer uses blueprints for printing an item. Blueprints are detailed construction diagrams that expand what the printer can build. Each object requires its corresponding blueprint to be printed. They must be stored in the printer's inventory. Open the printer's inventory by holding the Use key while pointing at it. This is the Creative 3D printer's inventory. Blueprints come as data disks. They must be stored in the data disk slots. Note that if you filter machines, then printers, you will access the list of objects required for building your own larger modular printer. Equipped with a construction tool, the modular printer is built the same way as a base. Now, let's have a look at the printer menu. First, close the Creative 3D printer inventory. This is the Creative 3D printer menu, where you have access to the printable items, depending on the corresponding blueprint stored in the printer inventory. On the left side, selecting a category displays the list of related objects in the central panel. Go deeper in the filters to refine your selection. Selecting an object will show its details on the right side of the menu. You can also see the Create button that initiates the printing process of the selected object. A holographic image represents the object currently printed. This helps you assess its actual size and also serves as a safety to avoid printing objects larger than the available space around the printer. That's all you need to know about the Creative 3D printer. Good job! Now the last part with the modular 3D printer. Close the printer menu. Now it's time to proceed to the modular 3D printer. The modular 3D printer is a realistic printing device. Firstly, its size can be increased by adding more pieces to a basic small modular printer. Edge, base, ramp extension, resources slots edge, etc. The larger the size, the bigger and more complex objects it can print. Secondly, it needs different types of resources for printing, depending on the object. Slots are available for plugging in any type of resources barrel. Objects that require more resources or a bigger printer are clearly indicated. Let's print something. Open the modular printer menu by pressing the Use key while looking at the control panel. This menu is similar to the Creative printers. The main difference lies in the required resources for printing, as indicated at the bottom right. Note that if you filter machines, then printers, you will access the list of objects required for building your own larger modular printer. Equipped with the construction tool, the modular printer is built the same way as a base. Now, choose the object you wish to print and create it. A printing time is required depending on the object. The bigger, the longer. Once printed, the object must be removed from the printer to free space for the next object. You can close the menu now. Do remember that you will need to enlarge the modular printer piece by piece for printing very large objects. Even a huge vehicle like a cargo truck can be built, provided that enough resources are available. Congratulations for completing the machine's training. That wasn't easy, but you managed it like a pro. Surviving on Mars should now be no problem. You can now pursue your training by using the board. Here you'll learn about the habitable base and how to build one. To build any base, you need foundations. We've prepared a small building for you to finish. An optimal building goes from inside out and bottom up. Finishing with the corner pieces should provide the best results. Start with the middle floor piece. To assemble the block, first pick it up with the Use key. Then equip the construction tool with the Equip key. Once the construction tool is equipped, you see all the connection slots of the block and structural leak points on your HUD. Matching connection slots on built blocks and held blocks will be displayed as well. The manipulation of objects is performed with the mouse. To rotate an object, hold the Pitch Roll Rotate key or the Yaw Rotate key and move the mouse. You can also use the 90-degree rotation keys with help located in the top left corner of your HUD. Congratulations, you've placed your very first block. Continue with the other two floor blocks. When the construction tool is equipped, leak points are represented by red warning triangles on your HUD. Great, the building is finished and sealed. Now it just needs power. You may have noticed the power socket panel on the floor. Connect it to the solar farm. Good job, the base is now powered. Proceed to the next part of your training. This is a 3-layered habitat. It has an outer shell that protects the insides from radiation and the environment. A middle connection layer maintains the interior environment temperature. And the last one is made of customizable interior panels for a homey feeling. Move through the airlock the usual way. Never forget to close the airlocks behind you. Your life is at stake. On Mars, no one can hear you scream. Basic habitat information can be seen on a wall-mounted screen on the left side of the room. Information is divided into several tabs. Go through them to continue. Room temperature and current power levels are in the Status tab. The Map tab shows you a satellite image of the current location. The Cameras tab gives you a live preview of the habitat cameras and a live feed from personal head-mounted cameras. You now have the knowledge to build and modify the habitat to your liking. When you finish building and powering your base, it is not habitable yet. First, you have to connect the oxygen to the resource sockets on the outside. Depending on its size, you can pressurize the base if you have enough oxygen. Size, shape, complexity, room and floor numbers are all up to you when building. The only thing restricting you on Mars will be resources, so bear that in mind when planning your base. You may proceed to the map for more training or look around. There is an outpost based next to the habitat.
T-minus 60 seconds. All systems.
For your first day, we'll start gently with the probe. That's the simplest vehicle you will encounter. The landing sequence is entirely automated. You can observe the fall via the fixed camera plugged at the front of the probe.
We're above the area, preparing for the drop. Ready for the drop on your mark.
You can switch to the external camera with the camera key to observe the automatic landing thrusters. Press the camera key several times to link between the different cameras. Great, that was a hassle-free landing. Now, before we start, there's some information to assimilate to remotely control the vehicle. Let's go through them one by one, starting with location info at the bottom left corner. Each element of the interface can be minimized and maximized by clicking the Minimize/Maximize button with the mouse cursor. Use the right mouse button to show and hide the cursor, then click on the Maximize button of the location panel to reveal its info. This panel shows local and earth time, the date, and even temperature and air pressure when the vehicle is equipped with an environmental monitoring station. The next one is the mission panel at the top left corner. You can see here the vehicle's name, the SOLs, for Solar Day on Mars. Let's go through. The Mission tab provides detailed information about the current mission and its objectives. Click on the Tasks arrow to switch to an overview of all the unachieved tasks assigned to the current mission. You can see here that only one task is scheduled. We'll get to it later. You will have noticed that an explore task has been automatically completed at the probe's landing. The explore task is always performed at each mission start. It confirms a successful vehicle landing. The navigation tab filters the waypoints displayed on your interface which are in relation to the mission's tasks. It also provides a live feed satellite view with vehicle tracking. The log tab logs events of the mission and vehicle. The Connect tab shows a list of all active vehicles in the same area and allows you to connect and take control of them directly. Now, close the current tab so we can continue. The vehicle's standard controls panel in the bottom is located at the bottom of the interface. The basic probe has no controllable parts. We'll go through the vehicle controls later. The probe consumes very little power to remain active, but will run out eventually. Currently available power is displayed as a blue bar at the top of the panel. Charge and drain rate fields indicate immediate charge and drain values in watt-hours. The bar at the bottom indicates the amount of auxiliary power in chemical batteries, which serves to refill available power. The basic probe has a single camera at its bottom and can have one single measuring instrument. The panel at the top right corner is divided into cameras and instruments tabs. Open the instruments tab. First is a list of all the instruments installed on the vehicle. Our probe only embarks on an environmental analysis station. Clicking on an instrument will highlight it. Highlighted instruments have their status and information displayed below the list along with a button to operate them. Double-clicking on the instrument will select it and open the instrument HUD. Now select the EAS. The instrument HUD that's just superimposed on the interface shows complementary information are the simplest, including controls to operate the current instruments. You can switch between three HUD modes: instrument, also monitor or analyze the nearby corresponding icon. This is exactly the screen you are assigned now. With the HUD key. You can have a look at it to the standard HUD and we can finally at the top left of the mission. To analyze the atmosphere, we will use EAS embedded in our probe. All environment instruments are usable without requiring any special position or distance to the target. Moving an instrument while it is sampling will compromise the sample process and you will have to start over. Congratulations! You have brilliantly operated the probe. This was just an appetizer. Now let's move on to the small lander.
Lander is ready for the drop. Waiting for your mark, over. Copy that. Proceed with the drop. Out.
Alright, landing phase initiated. Take this occasion to study the specific flight mode HUD. The landing target is clearly visible as a green circle in the middle of the screen. The yellow cross is the velocity vector. It indicates the vehicle's current speed and direction. Now at the bottom right, fuel consumption is higher because of Earth gravity but still in norm. Descent speed at top right corner is about 5 meters per second. Everything looks fine. Once landed, the lander switches to standard mode, displaying a standard HUD. As you can see, all vehicles share the same on-screen interface. Let's now have a look at the standard controls panel. It consists of primary and secondary controls. Their purpose is to control a specific element embarked on the vehicle. Scroll through the elements of this lander by clicking on the small left and right buttons of the primary and secondary interface. A mouse icon indicates that the selected element can also be controlled with the mouse. You can also scroll through the list of primary items with the switch keys. Then use the movement keys, or the dedicated 4 arrows primary interface to control the selected primary item. For secondary controls, you can also use the switch keys to scroll through the list of secondary items. Then use the movement keys or the dedicated 4 arrows secondary interface to control the selected secondary item. For a summary of the controls, open the options menu, go to the key bindings tab and select the vehicle section. The small lander possesses 2 robotic vertical arms that can carry a wide range of instruments. First, select the right arm by scrolling to the right robotic vertical arm with the switch keys, or by clicking on the small left and right buttons with the mouse. Good. Now extend it by holding the movement keys, or by clicking with the mouse on the 2 big up and down arrows of the standard controls panel to move the attached instrument close to the ground. Good. The instrument is now in range for analysis. Stop! Moving any further will break the arm. Speaking of analysis, a new mission has been assigned to the lander. Select the valid instrument required for the next analyzed task. This information can be found in the Tasks of the Mission tab in the top left panel. Then, select the instrument from the Instruments panel in the top right. Unlike environment instruments, active instruments like the Alpha Particle X-ray Spectrometer, or APXS, require an exact positioning in relation to their target. They are mostly mounted on a robotic arm for its ability to adjust their position and distance to the target. APXS irradiates a surface up to 100 mm away to discover elements contained in the analyzed area. Start the analysis when ready. Note that moving an instrument while it's sampling will compromise the sample process and you'd have to start over. Once irradiating is complete, the sample analysis follows. When the analysis is over, you can monitor the mission's completion in the Mission tab. And voila! You've done a great job. You've been assigned a new task. Repeat what you just learned to perform it. Assess the task, then select and make the proper use of the instrument. Good. Now you know how to use all the active instruments.
Hotel Actual to the control room. The site is clear. I repeat, the site is clear. Over. Copy that, Hotel Actual. Out.
All vehicles, with the exception of the basic probe we've already been through, can move one way or another. We've got another mission for you in this area. Open your map with the map key. On the map, you can see your position, and all available missions are marked with the pin icon. The nearest, and in our case, the only mission, is located to the right of your position. While the mission is selected, click on Humility, the name of your lander, and press the green Assign Vehicle button. Leave the map once the vehicle has been assigned to the mission. Lander thrusters serve not only for landing, but also for moving between nearby tasks or missions. To switch to flight mode, hold the radial menu key and use the mouse to click on Flight Away Point in the right box. In flight mode, HUD elements are different, and only the descent camera, mounted at the bottom of the vehicle, is online. Since we are testing on Earth, fuel consumption is greatly increased because of our higher gravity. Flying manually is possible, but the automatic system consumes less fuel, and we cannot afford to run out. This mission consists of photo tasks, so we'll use the Camera HUD and Cameras tab of the Instruments panel. To get pictures, we need you to move the science platform that has cameras 2 and 3 mounted on it. Depending on the distance between photo markers, you need to choose different cameras with various field of views. Now, take some shots of the launcher platform. Those are some nice shots. Alright, that wraps up the lander training. Oh, before we move on, did you know you can switch among multiple vehicles when they are in the same area? Open the Connect tab of the top left panel. You can see the probe we used before in the vehicle list. Click on the probe line and press select to switch to that vehicle. Good job! This is how you switch to other vehicles located in the same area. Alright, that's everything you need to know about the landers. Next up is the rover. Welcome to the rover part of your training. Rovers are mobile vehicles designed for the last years on Mars, while completing many different tasks throughout their lifespan. In that regard, they can be fitted with foldable solar arrays. The solar panels are folded in order to save space during landing. They should be deployed as soon as the vehicle is safely on the ground. Select the robotic solar panels in the standard controls panel and unfold them. Once fully deployed, you can check the power inputs in the power level panel. Depending on the conditions, a vehicle can obtain more energy from the sun than it consumes. Smaller or larger solar panels can be installed, depending on the vehicle's size, the exception being the probe. Keep deploying the panels to their final position. That's it. Now larger vehicles like rovers can be piloted thanks to their 6-wheel driving system. We'll try it right now with the new Explore task. Exploration complete. Now, keep moving to the new Analyze task that has just been assigned. It consists of a stone to analyze with the APXS. Switching to the instrument HUD will help identify the sampling area. Rovers possess specific robotic arms that unfold slowly into an L shape with a 180-degree rotation. Its head can hold several instruments, fully rotates 360 degrees sideways, and turns 180 degrees down. Position the rover with the robotic arm toward and close to the sampling area and unstow it. You can also use the robotic arm head to fine-tune the position and distance of the installed instruments. Remember, the instrument HUD indicates the exact distance between the selected instrument and the surface in front of it. Once the irradiating is done, stow the arm back so it won't break. Great, that is how you control the robotic arm and its head. Next we'll use the last type of instrument, which are passive instruments. Passive instruments require no action on the control side, but as environmental instruments they require you to be stationary in the task area. Drive into the next task area and stop there to complete the passive instrument analysis task. Note that passive instruments are not checking surroundings constantly, but in short intervals to save energy. Completing their task may take several seconds. Good job. Final part to go through is the top-mounted mast. This mast has only 2 low-powered slots for cameras, where the advanced mast has 3 slots and can be fitted with a chemistry laser spectrometer on top. The mast can rotate nearly 360 degrees sideways and 160 degrees up and down. The last task we have for you is to take a close-up coloured picture of the probe. There is a multi-zoom camera mounted on the mast, so you can look around using the movement keys, while the mast system is selected in the standard controls panel and the zoom 1 camera is selected in the cameras tab. If necessary, you can drive closer to take the picture or use the zoom function with the mouse or the plus and minus buttons of the camera HUD. You can use the mouse to move the mast if it's selected above the correct control panel. Nice work. This concludes everything we can teach you here. Let's move into the simulator to try out the Zero-G probe.
Welcome to the Zero-G probe simulation program. Program settings, basic vehicle controls and extreme environmental conditions.
First, the controls. The Zero-G probe can move and rotate in all directions. Linear thrusters control the probe's movements in all 6 directions. Select linear thrusters and use the movement keys to move forward, backward, left and right. Use the up and down keys to move up and down. Try out the linear movement. Attitude thrusters control the probe's rotation. Select attitude thrusters and use the movement keys to roll forward, backward and rotate left and right. Use the up and down keys to roll left and right. Try it out and move around a little for a few seconds. That's enough. You've got the hang of it. Now let's try that without the automatic assistance systems. To turn them off, hold the radial menu key and use the mouse cursor to click Cancel Kill Rotation and Cancel Kill Translation buttons. Now, move around for a few seconds, bearing in mind that if you rotate the probe too fast in any axis, it will eventually break. With assists off, you have to stop the vehicle yourself, including the rotation. Okay, stop the vehicle now. Use the Kill Translation button in the radial menu if necessary. The third and last assist is gravity vector alignment. This is applicable only in places with a detectable gravitational field. Turn it on through the radial menu. The probe will set its default rotation with the bottom towards the gravity and will always reorient that way. Try it out by rotating the probe a little. We're all set with the controls. Let's try it out with a task. Complete the assigned tasks with a combined knowledge of previous training courses. Good work. Now for the last part.
Simulating environmental conditions. Environmental conditions have been set to maximum.
If you look around the probe, you'll see meteorites hitting the surface all over the place. During this simulation, they will never hit you, so don't worry. But in reality, even a single meteorite is enough to destroy the probe. Plan the missions carefully, and always try to avoid sending missions to locations with bad environmental conditions. Okay, that is all you can learn here. Let's move on to the real thing. Welcome to the space program. We are in the mission control room, from where you will send vehicles to the surface of Mars on various scientific missions. First off, you'll be asked to choose between game time and real time. You may skip time if using game time, but time only passes during play. The real time setting is a bit more hardcore and does not allow time skipping, instead working with real life time. This choice is given only once, so choose wisely. Lastly, the top right of the screen gives you access to 3 important sections. Tech Research opens the technology development tree, where you can research new technologies that will offer even more possibilities. Encyclopedia contains detailed information and facts about the Red Planet according to your progression. The more objectives you achieve, the more articles you unlock in the Encyclopedia. Objectives lists all the various objectives you will have to complete in the space program. To move between areas within the Mars X Space Agency, such as the map, click the appropriate areas on the screen. Alternatively, for faster navigation, use the corresponding buttons at the bottom of the screen. The map serves as a hub to access new missions as well as ongoing missions. From here you will send vehicles to Mars as well as track your overall progress in exploration. By clicking on a location, we can see an overview of the location itself, displaying missions and vehicles on the surface. If we select a mission on the map, we can see general information about it, with more available in the mission details. Provided the mission does not have an assigned vehicle, we can send a new one to complete it, or assign a nearby vehicle on the surface that can complete the tasks at hand. Keep in mind that the vehicle list to the right includes both vehicles nearby and vehicles that would need to be launched, but only displays those vehicles that can complete the tasks required. From here, we can also connect to vehicles that are already on the surface by either selecting them directly or selecting their mission and then pressing Connect to Vehicle. Also, should a vehicle be severely damaged and unusable, we can shut it down by selecting it and pressing Shut Down Vehicle. Lastly, should you choose to send a new vehicle, you may customize it by selecting Vehicle Details, followed by Modify Vehicle, which will take you to the Rover Lab for customization. This is the construction lab, where you can manage the vehicles you have already created, load an existing vehicle, or create a new one. Provided your funds are sufficient and the technologies have been researched, you'll be able to come up with a wide range of very complex vehicles. To create a new vehicle, first, select the type of chassis in the list of available chassis and press the Select Chassis button with the left mouse button. Then, you can select the instruments you would like to equip your vehicle with. By selecting On Board, you can visualize the instruments that the vehicle has installed. And by pressing Add, you can browse the list of all the instruments that have been researched so far and make your selection. The icons on the right of the instruments list filter the instruments by category. It is then easier to visualize the slots where the instruments will be installed. Green for an empty slot and red for already used. You can rotate the camera by holding the right mouse button and zoom in and out with the mouse wheel. This comes in handy for better visualizing your vehicle. To install an instrument, choose the one you want by clicking it in the list. Then click on an available slot to finalize the operation. To remove an instrument, simply click on the red slot that contains the instrument. The requirements window contains a list of mandatory instruments the vehicle must be equipped with. The vehicle cannot be finalized if the requirements haven't been fulfilled. One last thing, to aid with decision making, each instrument that you select possesses a detailed description displayed in the right window of the screen. Once you're satisfied with your vehicle, you can test it in the Mars yard or save it. Select Back to cancel the construction. Welcome to the space program. We are in the mission control room, from where you will To move between areas within the Mars X Space Agency, such as the map, click the appropriate areas on the screen. Alternatively, for faster navigation, use the corresponding buttons at the bottom of the screen. The map serves as a hub to access new missions as well as ongoing missions. From here you will send vehicles to Mars as well as track your overall progress in exploration. By clicking on a location, we can see an overview of the location itself, displaying missions and vehicles on the surface. If we select a mission on the map, we can see general information about it, with more available in the mission details. Provided the mission does not have an assigned vehicle, we can send a new one to complete it, or assign a nearby vehicle on the surface that can complete the tasks at hand. Keep in mind that the vehicle list to the right includes both vehicles nearby and vehicles that would need to be launched, but only displays those vehicles that can complete the tasks required. From here, we can also connect to vehicles that are already on the surface by either selecting them directly or selecting their mission and then pressing Connect to Vehicle. Also, should a vehicle be severely damaged and unusable, we can shut it down by selecting it and pressing Shut Down Vehicle. Lastly, should you choose to send a new vehicle, you may customize it by selecting Vehicle Details, followed by Modify Vehicle, which will take you to the Rover Lab for customization. This is the construction lab, where you can manage the vehicles you have already created, load an existing vehicle, or create a new one. Provided your funds are sufficient and the technologies have been researched, you'll be able to come up with a wide range of very complex vehicles. To create a new vehicle, first, select the type of chassis in the list of available chassis and press the Select Chassis button with the left mouse button. Then, you can select the instruments you would like to equip your vehicle with. By selecting On Board, you can visualize the instruments that the vehicle has installed.